Hello and welcome back. In this video tutorial, I'll show you how to convert your schematic file into a PCB file and to export the footprint of each of these components into their footprint. So we have two files here. One is the schematic file and we have created a test PCB file. If you haven't created, just right click, file, and PCB. Create a new PCB file and save it. So then you can use this option, update PCB document, and here's the document name that will be updated if you use this option. But before that, I would like you to test and ensure that every component placed in this schematic file has a footprint. Okay, so you can select an item. For example, let me select again, and you can come into the property panel, and here in the property panel you can look for the footprint. Just click somewhere and you can see the 3D and the 2D view. If it gives you this view, it means that yes, it is added. This footprint is added to this particular symbol schematic. Alright, similarly we have the footprint for all of these, and but if you notice, in my case it seems like it's missing for this non-polar capacitor. Okay, it's for this one. Similarly for these guys, the footprint is missing. So I need to add the footprint. Whatever reason it's not being added, the most obvious reason is the library. If you can go to the library, non-polar capacitor, yeah, here it is added, but maybe at the time when this schematic was created, maybe the footprint was missing at that time. So it's okay. I'll show you first. If you export this schematic and still some of the footprints are missing, how can you go back and forth between the schematic and the PCB file? So I'll just go to design, update PCB document, and it will. Alright, just go for the yes. Then here in the bottom you have a room, and you can let's for instance I'll just keep it checked, and I'll just press validate validate changes and have a look. It says that the footprint for UAD UAD is actually, alright, this particular regulator. Okay, it says that the footprint is not found. Alright, so let's keep going. Okay, so I'm going to execute and then finally press close. So you can go to a little bit to the right and you'll find that all your components are placed here. And if you remember that checkbox for the room, this top the top in this the top box that's kind of pink, this is that room created, and in this room all the components are placed. You can just click and delete, and then you can freely move your components from one place to another. Then you can arrange it on this board area or whatever way you like. So here the things that are missing is the non-polar capacitor. Only one of the capacitor, non-polar capacitor, that is Ca2, is here. We have the footprint of only Ca2, and the footprint of the others are missing. Similarly, the other thing that's missing from here is the footprint of this guy UAD, and if I say click somewhere it says that footprint is missing. So we cannot trace this PCB. We will first ensure that all the components are here. Even if you like, you can start arranging them, and maybe in the first go you may not realize, but once you start placing these components, like for example I have the input here and the output capacitor here, and sorry, that's the input capacitor, and this one is the output capacitor, and similarly we have the other regulator. And let me oh sorry, that's not the regulator, that's the um, variable resistor, and here is our second regulator, 12-volt regulator, and this is the capacitor at the output. Please notice that I'm using space to rotate them, and that's just quite easy to rotate them by 90 degree, and you can use this technique. Alright, so what I'm trying to say here, that you can just put them the way the schematic is, like you can classify these components into the adjustable regulator. Like I'm placing the adjustable regulator on the top, then I'm placing here the fixed 5 in 12-volt regulator at the bottom. So here now you can realize that something is missing here, and that is the regulator itself. And moreover, this one capacitor, one of the capacitor here is okay, this is at the input. The capacitor at the input of this regulator is here, but the rest are missing because we didn't add the footprint. For instance, if I click here, the footprint is missing. Alright, so how to fix this problem? You have two ways that you can fix this issue. One is you can just go to your schematic library and ensure that the footprint is now added. Once you add it, you can use the component palette, and here now you can go for your library, schematic library, and drag this component here. Now you can replace the existing components with this one, and now you can see this when you click this guy, no footprint is shown, and when you click this one, it shows you the footprint here. This means that you can replace all of these guys with this new one. Another way you can do without adding this new component is just click here, and then you can add a footprint. Yeah, click here, add footprint, and you can browse to your PCB library. In the PCB library, then you can choose your footprint, required footprint. So now if you click here, it will show you that footprint. Similarly, you need to do the same process for the other capacitors. So you can add these footprints. Okay. Alright, so you can finish this job. Alright, so now we are done with the non-polar capacitors. And what about this one? Again, we are left with one component without footprint. So again, we need to add a footprint, as well as we need to add a component here. But for this, I'll show you that on the alternate way, so you can use it in the whenever you need. For instance, I have I'll just remove this and I'll add a footprint. For instance, we have TO2203. Okay, so I'll just add this here, and now I'm going to save this schematic library, and I can just close it. And now let me bring LM350 from component palette, and in the properties now you can see it has a footprint. Okay, I'll just name it one more time. I'll change its name to UAD. Okay, and now you can see the red line. It shows that there is a duplicate designator, and you can place it here. Save your schematic file, and one more time you need to update your PCB. Okay, press yes. Now press validates. Okay, now you can see that this area shows what we have, the changes that we have made. We have changed the footprint of those non-polar capacitors, C52, CA3, CA5, and okay, so all of them are changed now. And this time I'm going to uncheck this box and to show you that the pink box will not appear, uh, and you can directly right. So now you can see that the new components, and these are the components that were actually part of our circuit, but they were not included just because we didn't add their footprint. All right. So now they are added, and we can place them in the right position. Okay, now I want to show you another way exactly. Like for example, this is a particularly easy circuit. Uh, Comparatively, is little number of smaller number of components. But if you have uh, a circuit with several hundred of components, then it becomes hard to trace which component you are actually handling in the schematic. Okay, so you actually need a you need to have assistance from schematic. For example, schematic is a much cleaner picture of your circuit, and you can for example, you want to handle this guy, but there you might not be able to figure out where it is. So one way you can do is to go to tools and use this option. First, cross select mode. You need to just enable this, and now if you click, you can see that that particular component is selected. For example, I'm going to select this resistor here, and you can see that it also appears here. So this is a nice feature you can use, and you can go back and forth between these two windows. Another way you can for this particular placement, you can use, for example, split vertical option, and this splits your window into two. You can see your schematic as well as your PCB at the same time. So for example, you select this guy, you can move it somewhere, and then let's say you want to place this particular guy, then you can move it like this. So this gives you a much better idea actually where you what is the component you are handling. Okay, there are many designators, and you might not be aware actually where it belongs. Okay, so for this you need to use this particular feature. So for selection between for the cross probe, you need to turn on this cross select mode. First select this schematic file, tools, and cross select mode. Once it's enabled, you can select any of component here, and it gets selected in the other window, in the PCB window. And another thing you can enable here is in the tools, component placement, and reposition selected component. So if you enable this feature, when you select any component here, it gets stuck to your cursor. You can move it here. You don't need to search for it. It is selected once you click in the schematic file. So you just place it there. Another thing you can enjoy here is you can select two components, and you can see that one is shaded and the other is connected to your cursor. When you place one, the other will be pending, and then you can place the other one too. So you can enjoy these features, and if you don't want to if you want to disable this feature, just go to cross select mode, and you can see that there's a little box here that means that we have enabled this mode. You can disable this mode, and if you click any of these components, they will not get stuck to your cursor. So you can use these features to for the ease of your for your convenience, to make easy the placement of components. Okay, so the other thing you need to see here is that uh, the input. Okay, but before that, let me place them in a little bit uh, better way, and I'm going to close the schematic window first. Alright, so I have placed this 12 volt and I'm going to place that 5 volt here, and it is the adjustable regulator. So the reason I'm rotating these components is to make sure that the line that I'm going to connect, the trace that will connect these pads, okay, that should be shortest. Alright, so if I move it to the right side, then I need to track a line from here and all the way there, and then if I want to connect to the output, this terminal to the output, that becomes a problem for me. So that's why my focus is to rotate it in a way, to place it in a way that that makes my tracing, that is the next step, quite easy. So now I'm going to drag and drop. Oh, I better keep looking at this schematic file, otherwise it becomes difficult. Alright, so almost every of these components, each regulator got a pair of capacitor at the input and at the output. So at the bottom we have 12 volt. Keep it in mind that it's not mandatory to follow the same arrangement as in the schematic. What I mean is, you don't need to put 5 above and 12 below. It's up to your convenience, and you should think of what kind of arrangement can save your space and make the traces as small as possible. So don't think of it that I'm arranging it 12 below and 5 above just because it's in the schematic. It's not the case. For now, I'm just trying to make it a bit readable that uh, that that matches the schematic. In fact, so we have the CT1 and CT2. CT1 and CT2 belongs to bottom, okay, and since they are also connected in the same, all the capacitors are connected in quite a similar fashion, so it was hard to identify which one should I connect. And so similarly C51, so other guy I need is C52 here. Okay, so I'll just put that here, and then there is in the top case we have CA1 and CA2. There's CA1, CA2. Okay, they're right. And then we have the CA4 and CA3. They are here. Okay, we are just placing it random. I mean, not at the appropriate position. Just okay. What else we need here is C53 and C54. So here is C53 and C54. Here is C54. Down here we need CT4 and CT3. This guy. And then we have the CA5, which connects somewhere here. Okay, so for now this looks fine. Okay, we can at least classify uh, which regulator belongs to which capacitors, which set of capacitors. So okay, that's now better. So from here you can see that this circuit needs some terminals, all right, and we need those terminals to connect the input to this circuit and take out the output. All right, well, we haven't added these to our PCB. They are not appearing in our PCB. The reason is these are just nets. These 20 plus 24 plus 24. These are just nets. Similarly, these are just nets. These are not connectors. So whenever I left this part deliberately to show you at this stage that now we have all the components, but it's different from the simulation. Or in case of simulation, you don't need any external connector. You just have a voltage source. You apply one voltage, you get another, and that's it. But when it comes to a hardware, to your circuit, you'll plug in your input and you'll have a connector to take out to connect it to your load. So here, as you can see now, if this is our circuit, we have no option here to apply the input and no option to get the output. So for that we need to update our library. We need to update our library by adding, for example, a barrel jack. We need to add a barrel jack. So I'm going to use this free library loader, and this free library loader I'm going to search for the barrel jack. I'll just search. Alright, so I'll just add this guy, and all we need to just confirm is that it's a 24, at least it should be 24 volt. So I'm going to search this part number, that's PRT-00119. Okay, so I can confirm the specification. Alright, this is our barrel jack, and I'm going to minimize this and open the data sheet. Okay, so it's this one is a 16 volt 2.5 ampere, right? So this means that it's not gonna work uh, for us because we need a 24 volt jack. Let me see the dimensioning, and it says 20 volt and 4 ampere. So I'm gonna search for the second guy, that's PJ002A, and if I open its data sheet, then okay, the input voltage is 24. Alright, so this means we can use this guy. So I'll just press add to design. Okay, so want me to open, yeah, so just select your schematic and then press add to design. Okay, thank you. So now we have a barrel jack here, and we can use it for input. Okay, we have input this for the input, and you can confirm the pin out of this guy from here. It got pin number 1, which is pin number 1 is actually connects your 24 volt to, and 2 and 3 connects to the ground. So we can use this information in our schematic. Okay, and here is the footprint of it. Doesn't have any 3D, but it have this 2D. Okay, so it's just a little bit difference in the model number, because it's AH. So AH is a little bit different than A according to this. So we can search for this ASMT datasheet, that's different, and this is the datasheet for the surface mount, and it shows that 1 is the connected to the pin and 2 and 3 can be ground. So 1 is on the one side, and one of is on one of the side, and 2 and 3 is on the other side. We can ground the 2 and 3 pin, and we can use the 2 and 3 for ground. Okay, but here you might witness that 1 and 2 here, you can see that this underscore, that means that these two are actually connected with each other. It's 1 underscore 1 underscore 2. So we can use this for the 24 volt input, and we can use this for ground. So I'll just rotate it like this, and I'll just copy and paste, and now I'm going to connect this terminal here, and I'm using the ground here. Okay, and okay, so please know that 5 and 6 are we left them unconnected. They are just for holding the barrel jack. So don't need to use them. You can just use them for soldering, not for connecting to any net. So now we can save, and again you can use those steps we did in the previous module, that you can add this to your library, or if you want to use it directly, since these guys are the automatically generated libraries are here, you can also update your PCB and validate, execute. Okay, so the new component, as you can see, has been added. Okay, and now you can use it for I better name it something like J input, or maybe input is better. Okay, so the effect will not be will not be directly reflected on the other side, because when you update your schematic, you can update your PCB from here. So yes, you can execute and close. So you can see that your uh, designator has been changed to input. It was J previously. Okay, so similarly you also need a block connector, other kind of connector, maybe a header connector on for taking the output. So for that you can also take the steps that I just showed you. If you have the schematic library, you can search for the connector, miscellaneous connector, and you can go to, these are 10 pin connectors. You can look for a maybe 2 by 2, yeah, 2 pin header. You can use this for your output. And so you can just put it here and name it from the properties. You can name it variable plus variable output, and connect these like this. Similarly, connect this guy here, and make a copy of this, paste it here, and now use a different designator, for example plus 5. Please note that I can use the plus 5 output. Alright, so connect now this one here, here, another copy for the 12 volt. If you want to disconnect, just when it turns red, then you can, yeah, just like this, then you can press delete to get rid of that particular part. And now I'm going to name it plus 12 volt underscore out. Okay, so now our schematic is complete in the sense that we have a footprint for everything, and we can just see here we have a connector for the output as well. Yes. Okay, so that's it. We'll talk about tracing or PCB connecting lines, and maybe even we'll reiterate the placement to facilitate the routing. So we'll discuss that in the next module. Okay, thank you.